This conference will now be recorded.
All right. So we're gonna continue where we left off last week, which was chapter 8, the last very little section. This section is I really want to spend some time on it because this is one of those sections where that's a lot where people really drill you in an interview over this, over process monitoring. And let me open up another one here. But they really, the really thing of the really thing that they really drill you over is how to read top messages and how to read what CPU load average is. And while I'm doing that, let's go look at Red Hat documentation, and then type in system monitoring. And they usually have um, they actually have a dedicated section to this. But understanding here, we talked about PS minus, AUX, the POSIX, and I forget what they call it, POSIX and the other form they were doing. The minus is one way, and with PS minus AUX is one way, and then just PS AUX is something else. I forget. But here the top command. So let me blow this up, and then we're gonna get into the lab. I mean to the class. So it's kind of like you're gonna get information twice, but I just wanted you to know how to find their documentation, how to read their documentation, and then how to use the documentation when we get on the command line. All right, so here we're using the top command to display real time. So when somebody asks you, how do you look at processes in real time? Well, one way is the top command. Another way is the /prop directory is in real time. It gives you information about the system in real time. It says list is the real-time list of processes that are running on the system. It displays additional information about the system uptime. So let me go in here and let's jump down here. Let's go to read and let's go to the lab environment. Oh, why is it doing that? Oh, just because it's Ansible. It's the wrong one. I want the 124. Where did that go real quickly? Right here. Read lab environment. All right. And then let's hop on the workstation. All right. And let's log in with the password of student. Come on. Catch up. All right, there we go. Well, thanks. We'll close that and then hit activities. Why are you acting? Is this machine not good? Oh, they changed it. Look at her. All right. It used to be on the other side. All right. So here, what is that? Can't hover over. Oh, that's a new tab. Okay. And I'm searching. Okay. You can search. You see the interface has changed. All right. Full screen. Oh, look at there. Okay. Is this big for everybody? Let me know. We're gonna open up a cut and paste here.
Yeah.
Okay. And then you can also make it bigger on GoToMeeting as well too. All right. So basic commands. Who am I? I am student. I want a sudo to root, sudo su dash. Type in the word student. If I spelled it right. Yep. And the reason why I'm able to su or sudo to root in that manner is because of the etc sudoers file. I think it may be, they may have it under sudoers.d. Let me see, do I have it under there? Yeah, so then if we do lab sudo, See, they have the wheel group there. Here's what they can do for that one. Let's look at the 90 cloud init user. That user gets, the DevOps user does it with no password, and cloud user does it with no password. So let me clear my screen. Let's play around a little bit. So if I do it SU to DevOps, and what they're saying is because of the way it's set up with sudoers, I should be able to sudo dash without putting in the password, and I am, right? So back to who am I? I'm DevOps, so let's exit one more time. I should now be root. And then let's look at the sudoers file. Let's see. Let's look up, let's grep for student. Student's 99. I wonder where student is at. So let's go ahead and see if we can find out where student is at. Let me clear my screen. Let's see. Let's cat 90. I wonder if this student is just in the wheel group. And grep for student. And let's cat. Let's exit group. And let's grep for wheel. Yeah, okay, so the student is in the wheel group. All right, so what ends up happening is that group, the wheel group is stored inside of the sudoers. So let's look at cloud init and grep for wheel. So not there. And let's see if it's in lab sudo. I think it was in lab sudo, but I think I just saw DevOps, so maybe in the main file. Okay, so in the wheel group, you don't have to pass in a password on say these particular binaries, user local lib, something star, user local demo, bin, and then curl. So you don't have to have you don't have to type in a password for those, but if you're going to do anything else, you're gonna need a password for it. So that's how we find out what type of permissions that user had. This is really overall a recap of what we done, but I just wanted to iterate some things while we're here. All right, so now on our documentation, it says to run top, type the following command. For each listed process, the top command displays a process ID or PID, as we like to describe it, and the effective user of the process owner, the user, the priority, which is PR, the nice value or nice value in I, and you can reniece a value, meaning you can reniece a process, meaning you can give it uh, you can give it a different value, and we'll talk about that. Hopefully they'll talk about this. And then the amount of virtual memory, which is virt, and then non-swapped memory RES, and then shared memory SHR, and then they talk about the process with the status field. And we saw last week that the processes could have a status of S or an R or Z. I hope you remember that. The percentage, which is the CPU, the memory, which is mem, and then the accumulated CPU time, and the name of the executable running. All right, so one of the things that while we hopped on here, I can type in uptime. Now, uptime is going to tell me, it's going to give me my load average. It's going to tell me how long this machine has been up and then the time, right? And I also can check that with the date, right? So here you can see that this is in a 12-hour clock, and this one, the 24-hour clock, and this is in a 12-hour clock, right? You see that, right? So now let's go back over here. And they are showing you how to interact with top, right? So now if we hit enter space, this immediately refreshes it. If we type H, it's going to give us a help, H question mark, a helper screens for windows and field groups. K is you want to kill the process, and you don't need to remember all of this. Uh, you just need to know that it's an option available to you. And then some people like to use these things. Some people like to use like sort by user or sort by the list by memory usage. Like give me everything that's just sucking up all my memory and give me that at the top. Also remember, top is one of those commands that's resource heavy. So if you already have a system that's pegged, you might not want to use top, right? You might want to find something else to use. All right, so here they give you the actual GUI of looking at it, but we're going to look at it from the console. I mean, from the command line. So here's top, and this is what it looks like, right? So I just went over what the PID, the user, the PR, the needs, the virtualization, RES, the shared memory, the CPU, percentage of CPU, percentage of the memory, the time and the command that's actually running, right? So when we go back over here and we look at this section here, that's what they're showing: time, the accumulated CPU time, and the name of the executable. And RES is the amount of non-swap physical memory the process uses. All right, and then they show you that there. And then you get interactive. All right, so now over in here, describing what load average is. Load average is the measurement provided by the Linux kernel, which is a simple way to represent the perceived system load. So when they talk about the system load, have y'all ever used the system and you're like, even with your laptop, right? And you're like, why is my laptop spinning and it's running slow, right? Have y'all gotten that before? I'm sure you have, especially if you installing virtual box or VMware on your machines. I'm sure you've seen your machine slow down and just be like come to a crawl sometimes, right? Let me check my questions here. Yep. And so you have on your Linux, on your not Linux, but on your Macs, you have activity monitor to tell you what's sucking up all the processes in the CPU. And then you also have on a Linux box, you have top, but you can run top on a on a Mac. I don't think you can run top on Windows, but maybe you can in the subsystem unit. Now, hold on, let me tell you real quick. In WSL, you probably more than likely you can. So I got WSL open over here on another machine. Let me see what happens when I type in top. Yep. So in WSL, I can tell what's going on there. So I can do that there. But I don't know if in PowerShell can you do it. I don't know in PowerShell if you can do that or not. So if somebody got a Windows box, log into PowerShell. I know you got Task Manager, but I don't know if you can type top.
You can't. It won't.
Okay,
It's
you think
not,
so?
it doesn't see that command.
Okay, yeah. So you will probably have to make a binary and link it to Task Manager, and that will be your
It's probably like I hate PowerShell, man.
What'd you say?
You know, weird commands. I hate PowerShell.
Yeah. So I mean, hey, yeah, a lot of people like Windows. They love them.
Yeah. I don't know.
All right. So the kernel collects the current load number every 5 seconds based on the number of processes in a runnable and uninterruptible state. So what they're talking about is they're talking about up here, right? We're talking about what's going on up here at the top, and we're gonna get into that one. So now they say every 5 seconds, based on the number of processes in a runnable and uninterruptible state, the number is accumulated and reported as an exponential moving average over a 1, 5, and 15-minute interval. So when we're looking at it here, oops, when we're looking at it here, 1 minute low average is what I'm looking at. 1 minute, 5 minute, and 15 minutes, right? This last number, if you have this number going down, then you're okay. If that last number is going up, we might have some problems, right? Because over 15 minutes, you don't want that process to keep going up, because that means that something is going on, something is actively working, right? And it may be a good thing, it may be a bad thing, right? You don't want to never be pegged for CPU and disk reading right. You don't ever want your system, you don't ever want your hard drive, your network, and your CPU to be a bottleneck of why you can't move data or why you can't do something, right? So the kernel collects the current load number every 5 seconds based on the number of processes in a runnable state. Runnable meaning the R state, right? Well, the lettering or status symbol is R, not like French, but R. And then uninterruptible states. The number is accumulated and reported. Okay, yeah, we got that. All right, so now the load average represents the perceived system load for a period of time. Linux determines the load average by reporting how many processes are ready to run on a CPU and how many processes are waiting for disk or network IO to complete. So imagine you had you had a process running and it's sitting there just waiting for it to write to disk, and then it's sitting there waiting to, once it writes to disk, maybe send out a notification, right? Suppose you sent the email and you had to wait 20 minutes to get that email because it never finished writing the email, because number one, it was too slow. You had too many processes going on to actually get ready to send and then go out across the network, right? But there's other things. I was just using that as an example for waiting to write to this. You probably have seen this too. Say you're on say you're on your tablet and you're downloading a course, or you download a video, and the last thing you want to do is have a slow connection to download the video, right? And then even slower place to write to, like in other words, the disk that is going to get stored on. Can you imagine? You probably remember this, going over dial-up, right? Again, that was a network bottleneck there. And then the download could be the network download could be the bottleneck, and the when I say pipe, I'm talking about the network cord, or the ether, not the network cord, or the port that is on. The type of port was 100 megabytes or 1,000 or whatever the latest and greatest is now. I think you can get 10 with a particular card, but and up. But I mean, imagine you had to wait for that to transpire before you can even read the book, right? So the other one says some unit systems consider the CPU or the run queue length to indicate a system load. And Linux includes a disk network utilization because that can significantly impact the system performance at CPU. But not only can it impact the system performance as far as the CPU, but it could affect your job, right? Somebody may need for you to get something done, and you got a bottleneck on a machine, and so you're tying up your time and the person who's waiting on it, right? So let's get into it here. Low average is a rough estimate of how many processes are currently waiting for a request to complete before anything runs. So here they're talking about, let's display this low average, right? So we typed in uptime like I just did. And now they're trying to show you that uptime command is one way to display the current load. It prints the current time, how long the machine has been up, and how many sessions are running, and the current load average, right? So we say it prints the current time, it prints how long it's been up, right? Uptime, right? We type uptime, up 14 minutes. How many sessions, how many user sessions are running, 2, and then the current load average, and that will be this section here. Remember, 1 minute interval, 5 minute interval, 15-minute interval, right? The three values, the low average represent 1 minute and 1 minute, 5 minute, and 15. It indicates whether the system load appears to be increasing or decreasing. So what do y'all think? Is the system load increasing or decreasing? We got 1 minute at 292, and then in 5 minutes we got 448, and then in 15 minutes we got 520. So you think that's increasing or decreasing? No thoughts? It's increasing, right? If the main contribution to the low average is from the process waiting from the CPU, then you can calculate the approximate per CPU load value to determine whether the system is experiencing a significant wait. So they use the lscpu command, and we can type that. Clear. Oh, come on now. Clear. lscpu. All right, so here we find out a lot of things. We find out about the BIOS, we find out about the CPU, the model. We see that it's an Intel Gold 6248 CPU at 2.5 gigahertz. We see that virtualization is on. VT-X lets us know that. We also see that the hypervisor is KVM. And then we see what type of virtualization it is. It's full. And then we got some stuff down here about vulnerabilities and the NUMA. And then we got different flags that the CPU more than likely supports. And then we get the BIOS of this too, right? So it's a lot of little nifty information we get about the machine. All right, so now it says, for a moment, imagine that the only contribution to the load is from the process that needs CPU time. You can divide the displayed load average values by the number of logical CPUs. So it told us we got 4 CPUs right here. So we're gonna come back over here. How many CPUs do we have? We got 6 CPUs, right? All right, so then let's go back over here. And then they say, okay, you can divide by the logical CPUs in the system. A value below 1 indicates adequate resource utilization and minimal wait time, right? A value above 1 indicates resource saturation. All right, so here we were below 1. So we're above 1, right? 0.12 and 0.30. All right. So it's saying that the system load appears to be decreasing with a load average of 2.92 on all CPUs over time. So they're calculating this as a percentage. Okay. Behind the decimal. Notice that. Look behind the decimal here. Look. 12 and 30%, right? So let's read it. With a low average of 2.92 on all 4 CPUs, all CPUs were in use 73% of the time. During the last 5 minutes, the low average was overloaded by 12%. And then during the last 15 minutes, the system was overloaded by 30%. So it looks like anything after this, they're using that as a percentage, right? So when you get this 1, so let's go and look at what we're getting here. Let's pull out a calculator. So we got 6. It's clear. Let's do a top. Oh, we don't have nothing. I need to run something. My low average is, I feel like I'll be sure 0. Give it to me now. That's what it looks like. 0, nothing. Right? All right, so let's go back. We can't use that. We're gonna have to run something. I wanna get it off on your own, girl. All right, so per CPU, the load average was 73%, showing you how to read that. And showing you how to calculate this too, right? By taking your load average and then doing an LS CPU to find out how many CPUs you have, and it tells you the system load average appears to be decreasing over time. So they're looking at this at 73%. So I might have told you wrong, Lori. So 73% in the first minute, and then in the next minute we're at 12%. Or 12% overload, I mean 5% overloaded in the 5 minutes, and then in 30 minutes the system was overloaded. And during the last 15 minutes, the system was overloaded by 30%. Right? So that's what they're showing you there.
Wait,
All right.
how are they coming up with these percentages again?
They're anything above 1. So
Okay.
so the 1, they're just like, that's to me that's like a give me. And they came up with that right. What did they say that at? Where's that one? Right here. A value below 1 indicates the resource utilization and minimum wait times. So this was below 1 right here in the first minute. It says a value above 1 indicates resource saturation and some amount of processing delay. So if we know in 1 minute, 5 minutes, and 15 minutes, in that 15 minutes, it was some resource, the system was overloaded by 30%. And then here, the system was overloaded by 12%. But here we will find in that first minute, right? And they show you that here. During the last 5 minutes, the system was overloaded by 12%. In 15 minutes, it was overloaded by 30%. And in the last minute, it wasn't overloaded at all.
Oh, it's load average over the number of CPUs. Okay, okay, okay.
Right,
I got
right,
it.
right. It's a division
Yeah. All right.
of whatever the load average is, excuse me, on a per CPU basis.
Okay.
But if it's over, if every last one of these is over 1, you got some saturation going on, is what they're saying,
Yeah.
right? All right, so then it said an idle CPU has a load number of 0. And we saw that when I ran top up here. I'm not getting nothing. Just sitting there waiting on me, baby. Waiting on you. All right, so each process waiting for a CPU adds a count of 1 to the load number. If one process is running on a CPU, then the load number is 1. The resource CPU is in use, but no request awaiting. If the process runs for an entire minute, then its contribution to the 1 minute load average will be 1. Basically, you only got one process running. And in this case, it's no hit on the CPU, right? But they're just showing you if the process runs for an entire minute, which will be in this section here, then its contribution to the 1 minute load average will be 1. And that's one process, and its contribution to the load average is 1. And they calculate anything after the 1 as a percentage overload. So it'll be 0 back there, so there's no overload on that. If you're following that, Joan. So
Yeah,
if it
yeah,
was,
yeah. I
yeah,
got it.
okay, all right,
Yeah.
cool. Now, however, the process uninterruptedly sleeping for critical input output due to a busy disk or network. Now, this is when we're getting into it. The resource, disk or network resource are also included in the count and increase in the load average. While not indicating the CPU utilization, these processes are added to the queue count because they're waiting for a resource and cannot run on the CPU. So they're just sitting there waiting. And that's when you probably have to, maybe if you're like doing a batch job, have to give it the process a priority if it's something that you need to run. This is still system load due to the resource limitations. This is causing the process not to run. All right, so until the resource saturation, a load average remains below 1 since the tasks are seldom found waiting in a queue. The load average only increases when the resource saturation causes requests to remain queued. So anything I got sitting out there just waiting and ticking and waiting and waiting and waiting, they're counted, and they are counted by the load calculation routine, which the utilization approaches 100, meaning I'm just waiting because something just not finishing up. I'm just sitting here waiting, and people will keep submitting processes and stuff like that. So you're gonna keep submitting the process to run, but it's still waiting, and it's still waiting for another process to relinquish control so I can get on there and do my thing, right? And you'll see this a lot if you're doing like AI, machine learning, or any data engineering and creating models and stuff like that. That's when you start looking at this, because now you're trying to figure out, is this the right CPU? Is this CPU fast enough? Is this disk that we have, is that fast enough? Should we be using a GPU? What model GPU we should be using? Memory, and all memory isn't created equal. People like to tell you that some memory is better than other ones, especially when you start talking about in a, say, a laptop, or if you're in a iPad, or even on your phone as well too. All memory isn't created equal, right? So here they go through the different titles on top, and then they give you the process state. R for running, S for sleeping, T for stopped and traced, and then Z for zombie. And so then here's the interactive steps that they're gonna walk you through. So let's play around with it so you can see it in action. So here, if I type H, here's that help that we get. If I hit escape, I'm gonna go back. The other one is toggles for load, threads, and memory headliners. All right, or toggle the individual CPUs. That looks like a one, or a summary CPU header. Right. So let's go back over here and let's type a L. See, did we see anything change? See, type it again. I swear something changing, but I don't see it. Let me see. Toggles for load, threads, and memory headliners. So let's see if did the order change? PID user, did this change? Let me see. L. Is that a one? No, it's a L. I'm not seeing anything there. Let's see what happens on the T. Okay, there we go with T. I go back to L. Okay. But you see what I did when I did with a T, right? So you got
Yeah,
CPU, all right, CPU 0 and CPU 1. You see how that got broken out? Let me hit the tab again. I mean, not tab, but T. Let me hit it one more time. It gives you different displays of that. Right, you can get it in this format, right? You know, you can get it in this format. Uh-oh, I don't know what that happened there. I don't know why that went there. But you can see how it's moving now, right? Let's go back to one. Let's go back to
I
the other
think
one.
no, one gives you the number of CPUs.
No, I was hitting T.
Oh,
See, that was T, right? And then I hit one. One gave me the CPU, but it don't toggle between um the vision of it, the view of it, right? So if I hit T, I can get that visual that way. If I hit one, yeah, I got two CPUs, but I don't get the visual of that line there. That's what I was looking at right there. I got 0 and 1, and you can see the active processes on it, and then I hit tab again. I get that, well, not tab, but T. I keep saying tab, but I'm hitting T. All right, and then MC, L for the load, T for the threads, and M for the memory line. So let's go look at M. So there shows me my memory, right? And you can see I'm not swapping. We don't want to be swapping. We don't want to be swapping, and we most definitely don't want to be thrashing, because now you're just thrashing the hard drive. All right, so S is to refresh the screen rate. Let's go and do S. Change to, let's do, hold on. And let's see, let me go back to, yeah, so when I did S, I got changed the delay of how often I'm seeing stuff. So let's go back over here to S. S is change the refresh screen rate into decimal seconds, or in decimal seconds. So 0.51 and then 5. And then B, reverse highlight for running processes. The default is bold. Let's look at B. Oh, let me get out of that. Q, quit that. Yeah, go back. All right, let's go B. So it looks like it takes the process that's giving you the most usage of resources. See, does it come back? There you go, right there. And the C, it's going back and forth between that shell and so forth. All right. Then we got Shift B, the bold used to display in the header. And for running processes, then you got sorts process by process utilization in descending order. This again, it comes in here. This will come in handy in troubleshooting, but I don't see why you couldn't get this out of like a man page for top. So let's go back over here, and then let's quit and let's clear. And then let's do a man page on top. All right, so here they give you documentation, coloring, files, the whole nine. So they, 9 times out of 10, they probably have those shortcuts in here. And you may be asked in an interview, like, what is the low average? How can you calculate the low average? What's the significance of the low average? You're looking for poor performance, or some type of performance hit, or how it's performing on a machine, right? I'm just going through here to show you what they all have in here for this particular command. Any questions so far? Let's look at the lab. So in the lab, you're gonna start on the workstation this command. You're gonna type in that command. They're gonna have you SSH. Well, that's why I say you're gonna SSH to a server. And then in the left terminal, create a /home student bin directory. Write a shell script called monitor file in the new directory to generate an artificial CPU load. Make sure the script file is executable. So they give you these directions for you to hop over into this directory. Then what you're going to do is you're going to use Pico, Vim, or what have you, right? And you're going to put this into a script, and you're going to run this script. Let's read through the script. So the first line is letting us know that they're using the bash shell, or interpreter, I should say. And then while true, do this. Well, var equals to 1. While 1 is less than 60,000, then do this. Then add one more to var, which is going to make it 2. and then go back up, right? Go back up to the while statement. It's not going to go all the way back up to here. It's going back up, go to the second while statement. And it's going to just keep looping inside of this while statement until it gets 60,000. Right? And then when less than, because it don't say less than or equal to, it just says less than. Once it passes to 60,001, it'll break out that loop, sleep for a second, and then be done. Did everybody follow that? So let's
Yeah.
grab this. Let's grab this. And let's clear this screen. Let's go back here and open up another console. Okay. And let's come over here and go into the temp director. And let's make it work. Let's do this. Vim script.sh. And then we should be able just to paste that in. I hate when it pastes like this. Okay, so now we gotta line up everything. Okay, so the while loop is, we gotta line everything up. So while, we're gonna line up with the I for the var and the while. So var is gonna line up over here. Oh, let me escape. All right, and then we're gonna probably line it up here. And then, come on, done. All right, and it didn't copy everything. All right. Oh, that's because I didn't copy everything. All right, that's fine. Done and sleep one line up with each other. Right here. And then we need one more done. Right. So let's double verify that, right? So we got the var and done, they line up. The while is inside of that. The done lines up with this. Those should be four that line up, and then that while and that done line up. And do we have that? Yep, those four. Well, I can pull this over one more tick. Do. All right, so let's look and see what happens. All right, so we need to make this executable. So we're gonna do a chmod plus X on the script. And now in this case, I should be able just to do script.sh. So it's doing this thing. So now while it's doing this thing, let's go over here. Oh, it won't let me, it got the same thing. Ha 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 ha. It won't give me a different screen, but that's okay. We can come over here and we can do top. Now we can see we got some type of load on here, right? We can see our uptime went up and we got some load here running. And that's gonna run for, up there, it's right here. Dude, right here. Yep, still running. So what I can do, let me do this. So you're not looking at a blank screen. Let's vim this, and then inside this while loop, we're gonna echo you see me, right? And let's now run that again. You see that? It just, and I'm gonna put some spaces in here. You can see that it's still going. And it's gonna keep going. And then if we come back over here and we hit the top again, you can see what's going on, right? It's not oversaturated because of what? Is it what number? What's the magic number?
Greater than 1.
Greater than 1, right? Oh, look, it's saturated in the first in a minute there. You see that?
Yeah.
All right. Then we know the other one is says 31% saturated, 40% saturated, and then 13% saturated. First 5 minutes, first 1 minute, then 5 minutes, and then 15 minutes. Right?
Wait. So
Yeah,
the
so that
number above 1 is the percentages, right?
yeah,
So
but
it's
this
14%,
yeah,
and then this is not 44%. It's because it's less than 1.
but that's how they claimed it. Let me show it to you. Let's go back to it. Oh, it's not in this section. It is one back right there. Right here, see? It says all the CPUs in use approximately 73% of the time. And then really anything after the decimal is what they're looking at. 12% and then 30%.
In use, but it's not overloaded. Correct.
Right,
Yeah, okay.
right. Then but we got 1 though. But remember, it's not
Yeah.
overloaded if it's not above 1.
Yeah.
Right? We went above 1. Now we're down. Well, let me see. As it stopped running. Oh, I keep trying to change tabs up there. Oh, it's still running there. They have a top running there. Let me kill that. Let me kill that top. All right, we're still running. And I know it's still running because when I type that. All right, so we're still running. And see 31%, 37%, 16%. So this is just a good exercise just to figure out what is it doing, where is it going. Oh, it's over here. And what's going on with it. So let's go back to our lab. All right, and I didn't run the lab thing. I was just playing around with this script. And in this lab, they tell you to do a monitor, and then they do the top command, and then they come in here and do LSCPU, and then they tell you how to figure out that that low average. Was it the low average on each CPU when we divide it by the 2? Right? And so they're gonna come in here and have you do all of that. And you can use you only want this section here, right? So they did the top and then they gave you the user, and there's just what they're trying to show you. The user that's running, you can see my script.sh right here. And I ran it as root and it gave me my PID. It also shows you, if you're paying attention to it, how much CPU usage, how much CPU I'm using, right? I'm killing it. It's going down though, look, it's going down, right? It was at 40%. Going back up. No, yep, going back up. And then in here, they also show you the 1 minute load average is currently less than 1. The value of observed may be affected by resource contention from another virtual machine or virtual host. In the left terminal shell, which you can open up another screen, type monitor and then ampersand. And this monitor is something that they have in the on their some type of script or something like that on there. I don't know what that is, but you have to play around in the lab for that. And then they say top, and then they show you like the CPU, the memory and so forth. And then in the left terminal on a third instance, oh, I guess you need to open up some instances here. They have you put another monitor in the background, and they're playing with it, right? So this lab is going to walk you through all of that. And here we learned this the last term, SIG term, how to send different signals. Remember, you can do it's clear. I can do SIG. Was it SIG? No, it was kill-L, right? So you can understand what different kill signals are. Got it? And that's the lab. I didn't do all of it, but I got you started. All right, that's another lab for that. And then they have a summary and then chapter 9. All right, chapter 9. System D. So inside of RHEL 5, RHEL 6, I can't remember when System D came out. But System D came out, and System D, we used to be, to start a services, it would be services, the name of the process, and then start. And then System D came out, and Debian had been using System D for a while. Red Hat wasn't using it. Fedora started using it. If you ever want to know what's new and happening inside of what's going to eventually come to Red Hat, download the latest and greatest Fedora and start playing with Fedora and CentOS as well too, and you'll see what's going to be making it into Red Hat. It just gives you a good idea of what's coming down, what changes are coming, right? So with System D, we can control different daemons or start or enable processes, right? Here we can use System D to list the different daemons and networks that are started with System D, the servers and the socket units, Systemctl to start the processes and stop or what have you, or daemons as they're saying here. So I'm gonna let you read this. I do want to highlight what I talked about last week. The Red Hat, in Red Hat Enterprise Linux, the first process that starts PID 1 is the system daemon. The system daemon provides the following features: parallelization of capabilities, starting multiple services, which increase the boot speed and time. So anything you enable, Systemctl enable network, Systemctl enable bind, and that's going to start those processes on start, right? When I say on start, I mean the different run levels. You can have run level 5, you can have run level 3. That's really 0 through 6, but most people are only concerned about 3 and 5, right? 6 is a reboot. On-demand starting of daemons without requiring a separate service. Auto service dependency management, which can prevent long timeouts. For example, a network-dependent service does not attempt to start up until the network service is available. And that's a dependency that you can write inside of a unit file for System D. And Hopefully we'll get into unit files. Looks like we are down here. A service method of tracking related processes by using Linux control groups. So here, I'm a sudo to root, student, and then we're gonna clear. And now I'm gonna do systemctl list unit files, and I am going to pipe that over to less because it's gonna scroll my screen, right? And I'll show you what it looks like without less. You'll get some colors here, right? So you can see I have a state, a vendor, the unit file, and that's associated with stuff, right? You can tell whether something is when it's disabled or enabled. Those are nine times out of 10 servers you can start and not start, right? Start and stop, right? And we can keep going here by pressing the space bar, right? And I can just use the down arrow and that will give me one line at a time. Like you see, I'm using the up arrow and that's giving me one line at a time. But I have 415 processes or 415 lines. Another way I could have done that is I'm going to clear my screen, and then I'm going to do the up arrow and pipe that over to WC minus L. And then it would told me the number of lines. So we looked at 400 different, not necessarily start and stop or daemons, but just sockets, services, and processes to start and stop, right? You can also do a man on systemctl, and it tells you control the system, system and service manager. So they give you this here, produces output to the unit, whether it's low, it was active, sub, or description, right? And the sub is the lowest level activation state value depends. Let me, where my mouse at? Oh, here it is right here. So I was reading right there, right? And then if you just keep going in here, they tell you you can list sockets. They tell you can list timers. You can check to see if something is active. Has it failed? What the status is. And we can look at that. So let's do a systemctl unit. Well, we know one thing that's working off the rip is networking because we wouldn't be able to connect to this machine. So we can do status network. Is it network? Oh, it's not network no more. Awesome. Well, let's see what they have. Let's grab
Grab SSHD or something.
enabled. All right. Let's see. What'd you say?
Maybe SSHD might be working.
It should be, unless that's part of the lab.
Yeah.
Let's see. Let's go back. Oh, okay, fine. Systemctl status SSHD. Awesome. Yay. I don't know why network.servers didn't come up.
Because they're using network manager maybe for relay?
Maybe. But still, IPA. Yeah, you got an IP address on ETH0. System, CTL status. What's my options? Network service, network target, network online, network.service. I mean, I don't think I have to spell that out. It's just network. Yeah. Interesting. Why that didn't come up. But anyway, let's go back and look at SSD. So you can see here, it tells you that it's loaded from user lib systemd system sshd.servers. It is enabled. It is active, meaning that it is running. They give you some man pages as well too. They also show you the CPU, the memory, and again, the C group is what they were talking about. And then you can see here some information about the daemon for system, well, I mean, from system D, but SSHD. Another place that you can find out information is var log. And let me clear my screen. And let's do an ls on var log, and I'm going to double tab. All right, so in here, I don't see SSHD as a directory. So by default, it possibly could be that it's getting logged into messages. So I'm going to vim messages, and then I'm going to do the slash because I want to search for SSHD. Right. So, and because I'm searching, I can hit the N in here. Hold up. Let me hit enter. Then I can hit the N in here, and it's going to search everywhere in here for SSHD. And what you're looking for is the stuff that's highlighted in yellow, right? So we can hear SSHD server deactivated successfully, stopped and then stopping, right? And see, and on the right hand side here at the bottom, it's giving me the column and the paragraph. I mean column and the paragraph, column and the location, right? And then 39% of the file I've searched, right? And if I move over, you can see this number right here changes, right? You see that number right there changing, right? That's the column that I'm in, right? And also while you're in here in Vim, you can do escape and then set NU, and that's gonna give you the line number. So you can see here I'm at line 859, right? And column 56, just a FYI when you're looking at this. So I'm hitting N to keep going. And remember, I'm just looking for the stuff that's highlighted in the yellow. I'm not worried about the red. And let's see, okay, you see how I went down to the bottom of the screen already? See, I went through the whole file already. I'm at 39%, far right-hand corner, far lower right-hand corner. I'm at 66%. And now I'm back at 14. So I searched the entire file for SSHD, and that's what it came out with. So another thing you could possibly do, you could probably do a grep on var log messages, and then I'm gonna do a dash in oop, SST. I'm doing that wrong. All right, so here I'm just looking for the number of instances that SSHD showed up, right? That's one way, just using the grep command. Another way you can filter, you could have done a cat on var log messages, pipe that over to grep for SSHD, pipe that over to WC minus L, and tell you how many times SSH showed up in that file. SSHD showed up in that file. And if I just leave it this way, it's just going to kick out those commands from using cat and then grep. Then the other way I showed you grep, then the other way I showed you how to search the file, right? So you got multiple ways to skin a cat to get information that you want, right?
Sam, what was the N for again? Grep N? Grep? What was
Let's
that
go
for?
back. Let's do a man on grep. Ooh, yeah. Right here, the dash in. Right here. So the dash in will give you each output. Each output line is preceded by its relative line number in the file, starting with 1. So I wanted to know what line it was on. It was finding it on. So let's go back and look at that output. All right. So when I did it with the grep in for on this one, you see right here, it gave me the line number
Oh, got it. Okay,
of where to find that at.
cool.
The other ways, I'm just catting out, but I don't know where it's at in the file, right? But now if I pass it to dash in, tell me the line number.
Yeah.
All right. So a little bit more information, like, oh, go to line 609, and you'll see you got an SSHD there. Boom. Right. So any errors around SSHD in that area, da 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 da. So quickly learning how to search and debug for files, or within files and without even entering into files, right? So here now we talk about service unit descriptions, and we saw this. We saw service units, we saw socket units, and we saw path units. The service unit is an extension that represents system services. We saw that with SSHD, right? You can use service units to frequently access daemons such as a web server, HTTPD. So let's go install. Let's play around a little bit. Let's do a yum, which is the package manager for Red Hat. And let's do a yum install HTTPD and pass it to dash Y, because I don't want you to ask me. I just want you to do as I say. And this also helps with automation as well too. All right, so the package is installed, but it ain't doing nothing, right? So now we can do Systemctl status HTTPD. And look, it tells you the services here in userlib systemd system HTTPD. It is disabled, right? It ain't doing nothing. So now let's do Systemctl enable HTTPD. Okay, we created that symlink from multi-target to userlib systemd system HTTPD servers. In other words, when this system reboots, it's going to enable, and it's already enabled, it's going to start up the HTTPD servers. So if I made something to a configuration file and I need to restart the machine, when the machine restarts, it's going to use the current configuration file and actually start up, right? So the other thing we want to do is we want to start the service. Now, when we go back and look at HTTPD status, we get a different outcome. We see that it's now active. We see that it's also enabled, right? It tells us how long ago it started, the time. And they're getting better because they used to didn't tell you all this. It tells you the port that it's listening on, right? Tells you the memory and so forth. Now, okay, it gave us a lot of information, but let's go use our other ways that I've shown you to also grab this information. We can do a tail dash in the last 10 lines of /var/log messages, right? We can see here, starting the HTTP server on port 80, right? And when you install Apache on Red Hat, it's HTTPD. If it's on Debian, it's Apache. That's the name of the actual actual package or RPM or deb file, right? All right. Another thing we can also do that I have not showed you. Let's clear. Let's clear it, like delivered. We can do an SS dash tuna, right? And one thing we did notice when we were looking at HTTPD, it told us what port it was running on, and that was port 80. And we can see here, it's listening on port 80 right there, right? We see that. The old school way is netstat dash pant, and you'll see port 80, and it'll tell you that it's HTTPD, right? Another one you can pass the dash with pant that with a U, T for TCP and U for UDP, and it's gonna get UDP stuff. If you're not sure about any of these commands, do the man page on SS, and then you can go through. I did tuna, TUNA. So tuna numeric, A for all, and then U and T are the last two that you need to look up. So let's get down here to U and T. U is going to tell you whenever we get down here. There's the kill. It's the summary. Oh, there it is right here. T, TCP and UDP. Right. So I can go back up here and do SS tuna. I think I have to put -4 here. Let me see if it'll take it that way. Yeah. So 4 will be show me only IPv4 versus when I get rid of IP4, it shows me IPv6 and 4, right? So we see the IPv6 over here, and there's far anything in this bracket like that. That's that IPv6. So I'm gonna clear my screen and I'm gonna use my up arrow and show me IPv4. Right? And we see uh tuna. We don't see port 80 right here. So let me go back and get rid of that 4. And we see the port 80. It's funny it didn't show up there. I don't know why, or maybe I overlooked it. Let me go back and look at it again. No, I didn't overlook it. I don't see it there. But then it shows up when I do what I guess it just shows everything that only has IPv4. If it has IPv4 and IPv6, because I filtered on IPv4, it didn't show me that. I'm assuming, yeah, because this is probably an IPv6 notation, but it don't look like it though. All right, so that's that. The second part here, socket units have a dot socket extension, and they represent inter-process communication IPC sockets that systemd should monitor. If a client connects to a socket, then the systemd manager starts a daemon and pass that connection to it. You can use socket units to delay the start, excuse me, of a service at boot time and start less frequently used services on demand. Path units, meaning .path extension, is delay activation of the service until a specific file system change occurs. You can use the path units for services which you use to spool directories such as printing. And then they tell you can use the help that -T to help, and then how to manage system units and so forth, right? When using Systemctl command, you can abbreviate unit names, process tree entries, and unit descriptions. So here, let's do this. We did a Systemctl, they did a list units, and then they did it by type. They said -- type and only show me services. So basically on the unit side, show me everything that ends with a service. So let's change this up and let's do both. Let's do a unit and then let's do socket, because we know what type of what our options are. We can do a service, we can do a socket, and then we can do a path. So .service, .socket, and .path. Our how we type it is type equal to path service or what was it? Path, service, or socket. Okay. So it's clear. And then let's paste. No, no pasting. Oh, maybe I didn't copy. Copy and then paste. Oops, paste. No, you don't like me? Oh, because I don't have it turned on. That's why. There you go. All right, so we're gonna do by service. So see, it's gonna list everything that's a service, right? What's the difference in the command that I gave you earlier? The command I gave you earlier listed everything, but now we're doing it by certain units. So let's type socket, and it gives you all the sockets. Now they got a little something down here. Load reflects whether the unit definition was properly loaded. Active means high level unit active state, and sub means the low level unit activation state. Values depend on a unit type, right? And now we're gonna do, we did socket, we did service. No, did we do, no, what we do? Yeah, we did socket, service, and the last one is socket, server, path. All right, I should clear my screen so you can fall off. Now we're just going to use the up arrow and change this to path. So here's the path, right? And they tell you it's loaded and so forth, right? So we had socket, path, and service are the 3 units that we can use to filter to figure out what services we can use. We can use services to filter out what services are available that should be enabled. And then we got units, and then not units. Then we got paths, and then we got sockets that we can filter by. All right. So that's what they were showing you there. Here, the dash dash all option lists all the service unit regardless of its activation states, right? So back on our, we can go up and type here dash dash all. It might have been a dash all. Okay, yeah. So here, notice stuff that's not loaded or found. Notice that they got a little yellow here, and then they don't have. It tells you it's not found, right? You hit the space bar to keep going to give you more information, right? And then, again, without any unit files, we did that with Systemctl and then the CCL list unit files. I did it without a type, but we could have did it with a type. So let's go here and do that again. Let's run that command again, and then let's do it with a type. That's my type. That's my type. All right. And then boom, enter. And now we get that display with some color, right? What's disabled? Easy for your eyes to pick up and be like, oh, such and such is disabled because it's in red, right? You can pick that up really quickly. And we did this. I walked through that. I'm not going to explain this field because I went over that already. All right, so now verify the status of a service. Is it active? Is it enabled? Is it failed? And we saw that when we looked at a man page on Systemctl. So let's run through these. So we had this for SSHD. We know this service is enabled. We can do a couple of ways before I type. We can do Systemctl status SSHD, or you can do this here. It's active, and it says yes, it is active, right? And active relates to running. So let's change this to HTTPD because that's the one we installed. right? Do we get active? Of course. Now let's do a systemctl status HTTPD, and we get the same thing. Active is meaning that it's running. So if you didn't want all this output, you could do it this way. They made it easier for you this way when you want to, because it was hard to get whether a service was enabled or a service was in a script. I can see how somebody would use this. So let's say this. Let's say I had a script that had a for loop and says, I want to check these 5 services to see if they're active or have they failed. If I wanted to see if I had to use systemctl status HTTPD, I have to account for all this information here and how I'm gonna get that information out. So if I'm in Python, I'm a load Python, I'm gonna load up some type of control array or something that I can go through and manipulate to get this answer. But if I just use uh is it active or is it active, is it enabled, I can just hit act, I can just grab active and I can say compare the word active to active. Is that true? Yes, that means that it is active. It does active, what it returns, do these 2 strings equal each other? Does active equals not on? Not on and active are not the same characters or not the same string literal, then therefore this is not true. And so this is where I see this being a very good option for you if you are doing some type of automation, right? So now the other thing we want to check is this, even though it's active, doesn't mean that it's enabled by default. So when I hit here, I get enabled. Boom. Is enable equal to enable? Yes. Right? And then here they want to say to verify whether unit failed during startup. Like, oh, it failed during startup, but after about 10 or 15 seconds, it's on. So let's hit it here. Active. So let's see. It says this the command terms whether the service unit is able to start at boot time, which is usually enabled or disabled. To verify whether the unit file during startup failed during startup, run systemctl command is failed option. The command returns active if the service is properly running, or failed if an error has occurred during startup, right? So if it comes back with the word active is good. If it comes back with the word failed, or yeah, failed, that means there was an error. And that's what they're trying to show you there. And it says to list all the unit files, run the systemctl failed dash type dash dash type servers, and it'll tell you what all failed on startup. Any questions so far? Was that pretty straightforward? Was that fun? All right. I thought that was a fun chapter. Let me see. That was we did chapter 8.1, chapter 9. We have a guided exercise, and then we have now control system. All right. So now how do we stop and start a service? Well, we stop and start a service the same way we start a service using systemctl. Now we're going to stop a service. Okay, so well, we did that enable for the HTTPD, right? We enabled it, meaning that when I reboot this system HTTPD, you better come back up unless there's a failure in my configuration file, like I got an extra character or or I configured something wrong, or I got something running on the same port as something. When I do that, I can check its failed to see if it failed on startup. And if it did fail on startup, then I need to go in, troubleshoot, and then fix it, right? So in here, when we enabled, we said the command above creates a symbolic link to the service unit file, usually in this directory, userlib systemd system, to the location on the disk where the systemd command looks for the files, and which is in etc systemd system target name, systemd system target name. Enabling the service does not start the service in the current section. That's what we have to remember. Then it just enables it. We see we had to go one more step. We had to start it, right? Enabling a service doesn't start a service in the current session. To start the service, you need to do the systemctl start, right? And now we want to disable a service. So let's go back in here and disable HTTPD, but that's not going to stop it from running, right? So let's go systemctl status HTTPD. And now we're going to do systemctl disable HTTPD. And then we're going to go back and do a status. It's still running. I just disabled it from the boot process, right? So if I reboot it now, that service is not going to start up, right? But if I go back and now, if I hit enable, it's going to go back and create a symbolic link for me. And now it'll start on boot, right? So here they want to show you what your options are. You can do a status on a unit, right? And we know what the 3 units are, right? A service, a socket, and a path, right? But you can't start a socket, right? You can start and stop a service. So SSHD, you can replace that with this one. So we did a status, we did a stop, we did a start. We can restart. Restart meaning which is simple. Like, so rule of thumb, don't stop SSHD if you're on a box and your SSH in, restart the server so you don't lose the connection. If you stop it, then you got to go into the console and restart it, right? Or however you get access to that machine. The next one is reload. So if you change something in the configuration file, you need to reload the actual configuration. You need to reload the daemon pretty much so it can grab the new configuration. And then when in here, they're talking about mask, completely disable the service from being started both manually and at boot. So mask it out. Hey, don't even give that person an option. Unmask it, meaning reveal it. Enable, just like it says, enable a service or disable a service, and then list units required wanted by a specified unit. Let me see. 8. Boom! Lori, on time, finished. The rest is guided exercises. On time. Lab. And I even finished before the 15 minutes, Lori. Woo, 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 woo. Chapter 10, configuring SSH. We'll walk through that. I won't do it in 15 minutes. I won't hold Lori up. I know she's about to die. But next week, we'll come back and we're going to knock out chapter 10 and half for chapter 11. Then chapter 12 and 13. 13 is what? Oh, yeah, we could probably knock out 10, 11, and 10, 11. Yeah, we can knock out 10, 11, and 13 together. And then come back to chapter 12. I see how I'm feeling. Managing networking is not going to be that hard, but there's some subnet in there that we want to do. And then 14, installing packages. I went over RPM a little bit. You see me play with it, but we're going to hook our machine up inside the lab to their satellite server, and then we're going to pull in packages and play with repos and stuff like that. Chapter 15, accessing the file system using the find and locate. My favorite ones to use. A lot of people like to use find. I like locate because it just takes we can do that real quick. So let me give you that real quick. All right, so locate. If I type locate, is it in there? No, it's not. So if I do a yum install mlocate. It's gonna go out and get this. Oh, it's already started. It's already in there. So I just do an update DB, and it keeps a location of all the files on the file system, like a you could say like a database, and now I can say locate SSHD, and it's gonna search the entire file system for the word for SSHD, right? Boom, and I get that results back. Like I like using locate. Locate is great for when you already got a system up and you're not doing no more installs or anything, so you can just do locate. Find is like, hey, in real time, I got files that are being written to the file system. I need to use the file find command in order to find those things because they're in real time, right? That's where that comes in there.